Okay, one thing to bear in mind when you're given an integration problem to do is, particularly in exams, by the way, that you're going to be able to do it with the techniques that your teachers have been giving you in classroom. Right. So the first thing I notice is the radicand over here. Hoping it has something to do with a square. All right, and I'm looking at it; it's quadratic in form. I just don't see that thing being factorable. So I'm going to do like complete the square. So let me do this over here: x squared plus 4x. Now, if I complete square net, I got to take half of the 4, which would be 2, and square it would be plus 4. But you notice there's a 13 there, so I got to add 9 onto it. Now, what is the same thing as? This is the same thing as saying x squared plus 4x plus 13. It's identical. Right, now what I'm going to do is I'm going to, x plus 2 squared plus 9 equals the same thing as x squared plus 4x plus 13. All right, let me put the root symbol on it. So I got something pretty simple. I got this over here, that my integration problem really looks like this guy over here now. And what I'm going to do is, looks like this trigonometric substitution we've been doing in the past, by the way. So I'm going to say x plus 2 is equal to, what's square root of 9 is 3, and then a tangent of theta. Let's differentiate both sides. You get dx. On the right side, you're going to get 3 secant squared theta d theta. I can make my substitution now. And what do you get there? Put a little star here. And let's see what you get. Well, the dx is 3 secant squared. D theta. And what goes on the inside? That would be 9 tangent squareds plus 9. Well, I think I could simplify this. The 9 pulls out. Square root of 9 is 3. 3 times 3 is 9. I want to tell you what I just did over there. I took care of this 9 here, this 9 there. I pull it out, it's 9. Root of 9 is 3, and 3 times 3 is 9. I'm still seeing the secant squared theta d theta there. On the inside, I see tangent squared theta plus 1, which I know to be secant squared theta. Now, the invertible region that we pick for this, for the tangents between minus pi over 2 and pi over 2, and the secant is certainly positive in the interval, so I'm not worried about absolute value at this point. So I think I can take care of this pretty quickly. And what do you get? Let's set that down, star. You still get 9. The square root is secant squared in the interval of secant, so I get secant cubed. Now, if this is an exam question, I would hope you have enough sense to say, I think I've seen that guy before. It's local. If you're doing homework also, if you're doing it the way we would expect you to do homework, which is, spend a considerable amount of time on it, you would recognize that you just did that problem, all right? Now, what I mean by that, again, depending on your locality, what I mean by that, if you're working through the homework and you're in problem number 28 at this point, probably you can remember doing this one before. And the question is, did I do that one before? And I think I did. And I think we did this secant cube problem. And we did it, I wrote it down over here for you. Okay, I want to scroll back in the notes, by the way. It's right over here, number 24. What I mean by locality is that this 24 is very local to the problem we're doing now, which I believe is 29. It's not that far back, all right? Hope you can remember that. Was it effort to get through it? Yeah, it was some effort to get through that. Were we able to get through it? Yeah, we were able to get through it. All right, let's go back over here now. Where are we now? We are in now problem number 28. So where do we get to? We got this. I'm seeing that over here. And what do? I use it. That's all I'm doing. Right? I'm doing it. I'm just using it. So what I do is I plug it in. All right. So let's see what we got over here. Yep, we're still in the theta lambda thetas. So write this down. Basically just making a copy from a prior problem. And then I got troubles now. So what are the troubles? Well, if you thought about it, I have to go back to the original problem. And the original problem was not in thetas. It was in terms of x's. And my substitution I made was x plus 2 equals 3 tan theta. I'll write that down for you. X plus 2 is equal to 3 tangent of theta. All right? I want to remind you where we are, right over here. I need to go through this, and this could be difficult. As I do it, though, again, I want to recommend the invertible region of theta is between minus pi over 2 and pi over 2. It makes it a little bit easier for me to deal with this. So x plus 2 over 3 is equal to tangent of theta. I want to do a right triangle over here. Just help me a little bit. This is going to be x plus 2. And this is going to be 3. And the hypotenuse, we got to square the x plus 2, which is x squared plus 4x plus 4, square the 3, which is 9. I think I can handle that. So what do you get? X squared plus 4x plus 9 and 4, which is 13. All right, I think I'm ready to do this now. One step at a time, right? Wow, it's going to be a lot of work. 9. And I want to do the secant of theta. I want to emphasize what we're looking at. This is theta. I want the secant of it. And what's that going to be? Let's write this down. And that's over 3, right? Not so bad. Times the tan of theta. Well, that's easy. That's x plus 2 over 3. Plus, wow, natural log. It's 9 times that, though, right? 9 times the natural log, absolute value, and this is going to be over 2. And I got to do, oh, we just did it, secant. That's easy. That's going to be this over here. X squared. You know what? I'm kind of running out of room. And I hate to do this to you, but I got to erase and write it elsewhere. It's awful, right? And that was x plus 2 over 3, right? Plus 9, natural log. And it's going to be this over here. And let's see, plus the tangent, which was x plus 2 over 3. And this is over 2. Let me get my eraser out. Plus c. I'm going to simplify a little tiny bit. Seeing a 2 there. I'm going to call this C1, by the way. It's going to do something tricky. Now, let's see. You get this over here, x plus 2. And then you get the root of. We'll look at the key later. Then you get plus 9. And I want to emphasize here what I'm doing over here is that, if I were doing logs, this would be, the same thing would be 3. It would be minus the log, or I said minus 9 times the log of 3, which is a constant number. So I'm just going to integrate with this and call it a new constant, call it c. Put that over here. And what do you get there? The natural log, the absolute value, x squared plus 4x plus 13 plus x plus 2. All right, I'm going to put a commit mint box on it and see how we did. Let's take a look at it. Got that part. Got that part. Got that. Got that. Did we get this? Looking good. We're done. Thank you.